Have you ever tried to compare a software company's environmental footprint to a massive steel mill? Honestly, it's literally comparing apples to, well, steel. You just can't do it. You need bespoke, highly specific metrics to actually understand what's going on. So today, we're exploring exactly how the financial world categorizes industries to measure risk. We're zeroing in on the ESG rulebook for electric utilities and, crucially, why they are kept strictly separated from their natural gas counterparts. Welcome to today's Explainer.
To really understand this, we're going straight to the gold standard. The framework we're unpacking today comes directly from the SASB standards, which are now managed by the International Sustainability Standards Board, or ISSB for short. Listen, if you want to identify the sustainability risks that actually impact a company's cash flow and cost of capital, this is your definitive go-to guide.
All right, let's dive right in. Here's our roadmap for this explainer. We'll start with the SICS classification system, define what code IFEU actually is, discuss the strict natural gas exclusion, unpack why that exclusion even exists, and finally we'll look at the extreme precision required in these sustainability metrics.
Okay, kicking things off with Part 1, the SICS classification system.
The entire foundation of this framework is SICS, the Sustainable Industry Classification System. Think of SICS as a highly customized rulebook tailored for 77 distinct industries. It is absolutely not a one-size-fits-all approach. Every single industry has specific guidelines built around 5 core components: industry descriptions to set the boundaries, disclosure topics that highlight the big risks, precise metrics to measure those risks, technical protocols explaining exactly how to calculate the data, and activity metrics to normalize the numbers whether a company is massive or tiny.
Moving right along to Section 2, defining code IFU. So, IFU. It stands for the Electric Utilities and Power Generators Industry. But what does that actually mean on the ground? Well, under this standard, the industry is made up of entities that do 3 very specific things. They generate the electricity, they build and operate the transmission and distribution lines, and they sell that power to end users.
Now, to generate all that power, these utilities rely on a massive array of energy sources. We're talking coal, natural gas, nuclear energy, hydropower, solar, wind, the whole shebang. But here is the critical takeaway. Even if a power plant operates by burning a fossil fuel, like natural gas, this classification strictly revolves around the final output, and that output is electricity.
Which brings us to a really fascinating boundary-setting rule. Section 3, the natural gas exclusion. The standard is incredibly blunt about this separation. I'll just read it to you directly. The electric utilities and power generators industry covers activities related only to electricity provision, not to natural gas provision. This is a hard, absolute, non-negotiable line. Even if your local vertically integrated utility company bills you for both your electricity and your natural gas every month, they have to completely separate those operations for their ESG reporting. It's a total bifurcation. On one side of the divide, we have IFEU, strictly for electricity operations. On the other side, if that exact same utility company is sourcing and piping natural gas directly into your home for your stove or your heater, they must follow an entirely different rulebook under code IFGU, which stands for Gas Utilities and Distributors. So, Section 4. Why exclude natural gas? You might be wondering, why go through the trouble of drawing this hard line when so many huge companies do both? The answer is pretty simple. You have to follow the unique sustainability risks. Generating electric power means dealing with high-voltage lines, massive turbines, and very specific environmental hazards. That creates a fundamentally different physical and social risk profile compared to, say, piping pressurized natural gas underground. If you blended the two together in a report, you'd completely obscure the company's true risk profile. These highly specific disclosure topics mapped out for the IFU code really drive this home. They are perfectly tailored to the messy, complex realities of power generation. It's undeniable proof of why electricity needs its own bespoke set of rules compared to natural gas. Let's just rapid-fire a few of these unique topics to highlight the contrast here. An electric utility often has to safely manage literally millions of tons of coal ash. They have to handle nuclear safety and radiation containment. They have to worry about grid resiliency against highly complex cyber attacks. A natural gas distributor? Well, they simply don't have massive, heavy metal-filled coal ash ponds to worry about. It's a different world.
And to really cement this point, just look at the extreme precision of the data they ask for. For coal ash management, a company can't just wave their hands and say, "Oh yeah, we're managing it well." No way. They have to report the exact weight in metric tons of the combustion products they generate and the precise percentage that gets recycled.
For nuclear safety, it's a strict breakdown of total units by the results of their most recent independent safety reviews. We're talking about hard, verifiable data here.
Beyond just the power generation side, the standard is meticulously detailed about the physical infrastructure itself. Section 5, Precision in Sustainability. Which naturally brings up a major question. How do we actually measure something like grid resiliency? I mean, it's super easy for a utility to claim their grid is reliable in a flashy PR brochure, but how does an analyst genuinely quantify a grid's resilience against severe hurricanes, massive wildfires, or deep freezes?
Well, they rely on highly technical, standardized metrics to track power outages. You'll hear acronyms like SIDI, the System Average Interruption Duration Index, or SIFI, which tracks the frequency of those interruptions. And then there's CAIDI, which measures the customer average interruption. These are not rough estimates, guys. They measure electricity interruptions down to the literal minute to rigorously and universally evaluate how reliable a grid actually is.
And of course, sustainability extends heavily into human capital and workforce safety. Notice this 200,000-hour baseline. That number isn't just pulled out of thin air. It represents 100 full-time workers putting in 40 hours a week for 50 weeks a year. By using this standard formula to calculate the total recordable incident rate across both direct employees and contractors, regulators can perfectly, fairly compare the safety culture of a tiny utility with 500 employees against a massive mega-utility with 50,000.
Ultimately, this standard summarizes the incredibly complex challenge of the electric utility industry as exactly this: balancing the provision of reliable, accessible, low-cost power with the fundamental protection of human life and the environment. This meticulous, electricity-only classification is really the only way to provide the level of transparency needed to ensure utility companies are actually achieving that balance.
We'll leave you with this final thought today. As the transition to renewable energy rapidly accelerates, and grid technologies like decentralized storage and smart grids evolve at breakneck speed, how will these strict classification boundaries need to be redrawn in the coming decades? Will a rapidly modernizing energy sector require us to tear up this framework and write an entirely new rulebook? It's something to think about. Thanks so much for joining us for this explainer.